Hello, and welcome to another episode of the Project Catalyst podcast series with me, Kim Clyden. To date, the adoption of technology in sugarcane farming has centred around precision agriculture, relating to the variability of the land and resultant variability in yield to improve farm productivity and profitability. Whilst mechanisation continues to evolve, the greatest advances are being made in computer software integration. In 2021, Alex Olsen and Mostafa Rahimi presented their robotic weed spraying technology at the Project Catalyst Forum in Townsville. Since then, they've collected data to train the AI or artificial intelligence program to identify weeds of concern and conducted replicated trials. Alex, how have you been able to advance the technology through the trials you've recently conducted, and where did it all begin?
We had a unique approach to weed detection using artificial intelligence that really, due to the recent boom in technology in the last 10 years, artificial intelligence has really taken the next step and unlocked a whole bunch of applications for speed and accuracy of detection with using imagery. And this hadn't been applied to the agricultural space for weed detection. And that was the purpose of our postgraduate research. And at the end of that postgraduate study, we found that we had something that Australian farmers could really actually use today, not tomorrow, because of this technology had advanced. And so as a result, AutoWeed was spun out from James Cook University, and we looked at commercialising this research for Australian growers. But also, one critical aspect of this is we hadn't applied it to sugarcane. And that's where I can let Mostafa talk about the approach of this technology to sugarcane.
Yeah, so how did you come to be working in that field or have knowledge of sugarcane in the first place?
So we have applied AutoWeed technology during Alex's PhD and to crops, to other weeds in basically rangeland. And we saw a lot of potential, and then there was a call from the Great Barrier Reef Foundation for innovation in improving water quality. And we thought, okay, this is exactly where this technology would shine, because we are reducing the herbicide that the farmers would need to put basically in the paddock, and that would result in reduction in herbicide. And this is a cool technology already. We have shown it that works in other crops and other basically rangeland environments. Why not try it for sugarcane? And then we talked with Alex. It was the two of us in the very beginning. I started the discussion and thought, okay, this is perfect, and this is really aligned with what we want to do. And sugarcane is here at our doorstep. We are in Townsville, up north, down south. It's all sugarcane,
and lots of
it. It's just and that's how we actually started developing the system for sugarcane and for the weeds in the sugarcane industry, and that's a big problem. And we focus on the Berdican area because it's, again, the closest to us. An hour drive from Townsville or less, and we are there already on the paddock and basically doing what we want.
So almost 2 years ago now, in February 2021, you both came and did a presentation at our Project Catalyst Forum. What sort of feedback did you get post-presentation?
Yeah, it was tremendous, actually. And it spoke to how well Project Catalyst sort of integrates with the growing community in like for us in North Queensland, but the whole state and Australia, because the feedback was just, it's great to see this technology that could also save, benefits for the environment, but also save us dollars in our pocket if we're putting out less herbicide. So it's really a win-win. There's nothing that putting out less herbicide will sort of not be good in some way. So it just put more pressure on us to go, let's get this technology right. Let's make sure that we actually trial it correctly and ensure that it is delivering the savings we want on the environment side in terms of water quality and the costs, that we're reducing herbicide. And so that it just put more pressure on us because the response to the growers was so good. And we're very pleased to say that since that first Project Catalyst talk, where we were really just talking about what we're planning to do, the 2 years have passed and we've had 6 very good spray trials showing the efficacy of this tool.
Mostafa, how did you identify the sites for the trials?
Okay, that's a very good question, because it has been one of the challenges that we have been having. But thanks to our partner organization, Sugar Research Australia, and like the very key people in that organization, Terry Granshaw and Emily Philos. They were fantastic in basically, and Terry has been in the region, has been a farmer himself, and he knows everyone around the region. He's really keen for this technology, and he's really interested in basically giving back to the community and talking to the growers. And through him, we find and identify growers who are interested in adopting the technology, or at least trialing it. And that's how we basically find the paddocks, and we go. And it's not just one go or two. Sometimes we have to go a couple times. And it's just a lot of interaction with the growers. And it's been really fantastic interactions, and we have seen only good. So it's been.
We can also add to that just the weeds and crop scenarios we've targeted have been quite selected. So nutgrass in early stage ratoon cane is a costly herbicide to deal with. You have to use Sempra, which can be $200 to the hectare to treat it. So that was one that we sort of earmarked as a great starting point, because if you're going to show herbicide reduction, the cost savings would be great for that application. So that was one area. So we did 3 paddock trials of nutgrass in early ratoon cane. We also did a trial on nutgrass in early plant cane. And we also did, while the sugarcane paddocks were kind of not in spraying season, we targeted mung beans paddocks for broadleafs and grasses in the same paddock. So for us to, let's say we've never seen a weed before, never seen a crop before, we need to collect data inside of that paddock at the time that spraying would be required. So we can capture what the weeds look like, what the crops look like, in order to train our detection models. So for us, we hear from Terry that we have a paddock and a grower ready to participate. Within a couple of days, we're sending our data set collection system to the paddock. For us, we've got an ATV, a UTV, and we can also install on a tractor some cameras that actually collect the images. And that's just one day of data set collection. And then that would be followed by some labeling of the images. So the images are manually labeled, a small subset of them is, in order to train the AI to detect the weeds. And then the next step would be actually testing that model's performance in the paddock. So we call that a dry run, where we take the camera system over and it's sending it's basically just flashing a light to show where it thinks the weeds are, and we're able to sort of look at it and calibrate it for the system. And within 2 weeks from dataset collection, sometimes a week, we're actually ready to spray that paddock. And that's the trial work. Then from there, it takes another step, because we have to be very specific in how we're comparing the spot spraying approach to the existing standard approach, which is blanket spraying the whole paddock. I'll let Mostafa talk about some of how we laid out our plots.
What sort of replication did you have to do to achieve the results?
Yeah, the replication has been like something that we have been thinking about since the beginning, because we are also interested in the water quality improvement. We are putting less herbicide. Can we see a lower load in the chemical running off from the farm? And that's exactly what we've done. And we don't want to do once. We want to do it multiple times, and we want to see the basically consistent result. And that's for each of our trials, as Alex said, we go and collect all those images. We label some of the images. We train the algorithms. When the trial day comes, then we say, okay, now we want to have a good replication of what we are doing. For that, we take 13 or 12 rows. We spray them with normal blanket spraying technology, and the way that this is the actual industry practice. Currently, everyone is doing that if they are not using our technology. Then 12 or 13 rows, depending on which vehicle we are using and which sprayer we are using. So then another 12 rows next to it. One was blanket spray. The next 12 rows would be a spot spray. Another 12 rows blanket spray, and another 12 rows a spot spray. And then why we are doing 12 rows? Because we want to be able to measure the water quality in the middle of one of those 12 rows, say row 6, row 5, so that we know that like the drift or from the blanket spray or the spot spray to the other rows are minimized.
Or even the overlap between the nozzles, that you can get some cross-contamination just with the standard practice usage of the nozzles. So we needed those large treatment areas.
Yeah, and across all these different trials, 6 trials we have done, and we've seen real good results. But how do we know if the herbicide that we have put for the blanket spray is, or for the spot spraying, is as effective as blanket spraying. Alex would tell you a bit more about that.
As you're using your sprayer, our system just sits on the nozzle end. So it doesn't actually have to interfere with your flow rate controller or anything like that. So you can actually use your flow rate controller to measure your herbicide output. Or we read the tank as well. So we read the tank, measure the herbicide output, and we just directly compare after a spray job of one treatment area, how much herbicide liters, total chemical mixture did you put out? And we do that for the blanket, we do that for the spot, and we record over time. The herbicide reduction is very easy to measure. The thing that we had a bit of an interesting issue with was measuring the efficacy of the tool across the trial area in terms of, how is the weed knocked down? How effectively are we knocking down the weeds? So to do this, we actually used drone technology. We did a drone scan of the paddock during the spray, just before the spray, and that allowed us to take a snapshot before. This is what the paddock looked like before the spray job. Then we come back, depending on the chemical, a week later, sometimes up to 2 weeks later, to see that the chemical had taken effect, and we do an after spray with the drone. We do this at a very high resolution, so about 10 meters above the ground with 2 pixels per millimeter resolution. That allows us to actually see individual weeds overlap and say, is it dead after the spray job? And then all we have to do is count the weeds hit, count the weeds missed, and divide that by the weeds total, and we get a measure of weed efficacy in terms of how well we're knocking down the target job. And we're able to do that in blanket spray versus spot spray. So we have an average of performance for blanket spraying and spot spraying.
You're listening to the Project Catalyst vodcast with Kim Clyden, speaking with Alex Olsen and Mostafa Rahimi about their robotic weed sprayer technology. So Mostafa, what were some of the results that maybe caught your attention the most, something you weren't expecting?
Of course, there were a lot of challenges that we thought, okay, we will basically go and spray, and we see the technology always working. We saw few challenges that we are currently working on, for example, like the technology when being a bit sensitive to maybe lighting conditions, and we are currently working on that. This is not a big issue, but when you actually go to the paddock, when you apply the technology, you see all these challenges. Before that, we were aware of them, but we basically saw the effect, the actual impact in the paddock, and we are currently working on that, and this is definitely addressable. One thing that we saw, and it was really interesting, it was basically if the weed pressure in some rows is low, we can really save herbicide. We can save up to 75%, and that's because this is one row that has. And currently, you don't look at it that this row or this part of the paddock has less weed. You just go and blanket spraying everything. That's why you can actually, if there are some parts of the paddock, some rows that basically have a much lower weed pressure, this is where this technology shines, because you can basically reduce the herbicide significantly. Mm. Sometimes, on the other hand, you go to a paddock, you sit and you say, no, this is not good for this technology because it's very dirty. The weed infestation is quite high, so you may as well blanket spray the whole paddock. These are the sort of things that we have seen, and if you basically, the technology would be good if you want to stay on top of the weeds earlier. If you just let it get out of the control, I guess that would be the time that...
You won't be saving any money then.
That's right, yeah, absolutely, yeah.
Alex, how have the growers you've been working with responded or reacted to some of these results?
Yeah, no, they've been very happy. So we've worked with all of our trials have been in the Burdekin region. So we've worked with sugarcane growers, large and small, and just a couple of good feedback we've had is from a few of the growers from our trials. We had them sort of monitor while we were doing water calibration tests. They were able to sort of observe the spraying in the field. So it wasn't spraying chemical, it was spraying water, and they were able to actually see it hit its targets. As it was moving along, it sprayed, and the farmer said, hang on, I think it might have missed something. And he came back to have a look, and there was a very small nutgrass. And he said, okay, no, it's actually picked up a tiny bloody nutgrass. Yeah. And so he was very thrilled to hear that it had that level of precision, even in that situation. And to him, it matched the performance of the blanket spray, giving him the savings he wanted. So he was obviously excited.
How much has the design changed since you've actually applied the technology?
Actually, it hasn't changed too much because we've been actually designing and built AutoWeed. We've built these prototypes some time ago, about 2 years ago, and just before that, we basically had to figure out how to attach them to the sugarcane systems and how to have it work for urban leg spraying and spraying at the spacings for sugarcane. But our camera and processor system has been pretty good and the same for a while now. We want to put these units through the ringer and see everything that could go wrong, so we can fix them and be ready for commercialization. So we have learned a lot along the way about how we can add to the system as we're going to make it mass producible for the industry.
Given that you've been able to access Great Barrier Reef Foundation funding, how has that assisted you, and what does it mean to you to have that type of support?
It's been fantastic. Yeah, we couldn't be more gracious for the funding that the GBRF has afforded us to actually bring this technology to sugarcane and see how effective it is. It's allowed us to really, get going and on it. And we owe a tremendous, gratitude to the GBRF, and they've actually extended our project to do another year and a half of work where we'll actually be able to trial the technology for different scenarios across the wet tropics region and the Mackay-Whitsundays region. Because, as you know, sugarcane systems vary drastically from region to region. So the extra funding from the GBRF is going to allow us to do that testing and also look at the economics of this tool. How is it going to actually impact farmers on the bottom line when it's adopted? Does the capital cost outweigh the reductions that we'll see? So they're the answers that we're hoping to address in the extension project.
There's been a lot of global discussion about artificial intelligence, or AI, particularly over the last decade. Alex, how can you assuage any fears farmers may have?
I'm of the opinion that artificial general intelligence is still a far ways away. What we have is very highly optimized decision-making tools that are as good as the data sets that we collect to utilize them. And at some level, they're controlled by humans. So fortunately, we've got the human ability to moderate our data sets, train our tools, and deploy them for the given tasks that we need. But that does put responsibility on us as the engineers putting these systems out into the field. So we need to make sure that those systems are kind of safety guarded so that they're not making decisions that could cause herbicide to be sprayed in areas you don't want it sprayed for our given application.
Well, the other thing is the data sets. I mean, a lot of growers are concerned, particularly with regulations from the government, that data could be used against them. So you're out there gathering a lot of data about their farm, their herbicide use. How is that safeguarded for the farmer?
Great question. We feel this technology could really be great for farmers for actually showing their herbicide usage in a more precise way going forward. So if you use this type of system, a general output will be a spray map. You can actually get high resolution map of where the herbicide's being applied on your paddock. And that's data that hasn't existed before. So this should be music to growers' ears, because they'll be able to have, there it is. Here's a great report of where all my herbicide has been applied over the last 5 years to the centimetre about where it was applied. So as a grower, I'd look at this as a very exciting opportunity to protect the knowledge of how I'm using herbicide on my farm and know that it is concrete, so that if someone does come asking questions, they've got concrete evidence of how they're applying it. And your other question there on data security, that's a very important question. So if data is collected on the grower's paddock, they would have probably the right to assume that they're using it for the benefit of their application on their farm. And that's totally at their discretion. So it's going to be a very interesting thing. We just want to make sure that the database storage is safe, it can't be corrupted in any way, and that we're using it for AI models to improve the productivity of their farm. We want to build these systems to be standalone. We don't want them to have to be connected to the internet to be able to work, because you talk to growers, they want a tractor that, there's nothing that is worse than not being able to use their tractor because the GPS is having a trouble connecting, and a variety of other apps that they might utilize. So we have heard from the growers, and this tool needs to be delivered in a standalone capacity. All that we need to do is have the model trained and sitting entirely on that system so that it's boxed up and ready for them to use, and they don't have to connect offline to do it. However, with artificial intelligence technology, every sort of couple of months, we will need to grab the latest bunch of data to improve the model so that it is actually learning new weeds that they want to target. So there is an element of connectivity that is essential to maximize the usability of these tools. But on the day of spraying, it doesn't have to be connected to the internet. They can go and do their job with their tractor. So that's definitely something we've heard and want to address. It is critical to say that all of the AI processing happens on board the vehicle as it's moving. So that's where our expertise has been to achieve that. It's not going back to the cloud to get a result and then making a decision. It's all on the tractor.
Mostafa, obviously there's next steps, and like Alex said, this isn't ready to go to market yet. So where to from here?
As you remember, we said we go and do water quality trials after each spray trial. So we have the same paddock that we applied this spotter spraying technology, AutoWeed, versus the blanket. We wanted to see how much herbicide did we save. We know how much herbicide we put from our spraying trials. Then we go and see, okay, does this really basically show itself in the when you go and measure the chemicals in the runoff? So we induce runoff with irrigation, and then we go and grab samples and send them to the labs, and they measure, yes, this row that you pick, and we knew that there was this much of herbicide put on it, and these many weeds has like X% less, and we have seen real around 40-50% reduction in the herbicide, basically
Measured in the water.
Yeah, measured in the water, and that's what GBRF really is interested in. And they also see that the technology is really popular among the growers in the region. They have seen us basically talking to the growers, and they have seen the feedback. So that's why it made sense for them to just go and say, okay, this is a project that we have to fund further to go ahead. So, and that's where we're going from here. We have shown the technology can be as effective as blanket spray, nearly as effective, 97%. We have shown that it can actually save the farmers some cost. We have shown that it basically reduces the herbicide in the runoff. From here, we want to improve the system to basically integrate into it those extra details that the farmers would like. For example, can we, if we are spraying 2 different herbicides because we have 2 different weeds, can we do them at the same time while you are basically traversing this road? We don't want to do it twice because that's twice as much work,
exactly.
right? So this is one thing that we are targeting. So it's a dual herbicide sprayer that we are going to use, and we are going to basically develop for this next phase of the project. And AutoWeed has currently this new herbicide. It was just the one that I was talking about before. As soon as I arrived, I asked Alex, "Where is this?"
At the back.
Because it's at the back. And then all the other things, because it's actually again, Alex said it's a standalone system. But this standalone system can, what stops us from basically controlling from this one system 2 different solenoids and two even different nozzle systems. So nothing. We have to just only implement it. And that's where we're going from here. There are other things as well that maybe Alex...
Oh yeah, that one's huge because you can put down your pre-emergence in the same pass that you're putting down your knockdowns. And it might be, I'll just have the pre-emergent on for the entire spray job and selectively apply knockdowns. We even had a trial in our last project where we hit broadleaves and grasses in a mung beans paddock. And so we could theoretically, if the chemical mixture is able to be mixed, you could do both those sprays in the same pass with 2 different herbicides. So yeah, the labor savings are just huge on that. And one other little thing that we're looking to do is the possibility of doing a spot spray of pre-emergent herbicide. So it'll depend on the weed and whether the seed bank comes back in the same locations. But if we actually have those spray maps that I'm talking about, where we know where the weed seed bank is, we could come back the next season and just put the pre-emergent only where it needs to be. And pre-emergent herbicide can be quite costly. And it's also a PS2 herbicide, which lingers longer in the soil. So if we can reduce that, that's even adding more value.
You've been listening to Kim Clyden with Alex Olsen, Managing Director of AutoWeed, and Mostafa Rahimi, Associate Professor at JCU in Townsville and Project Lead for AutoWeed. Join us again next time when we'll discover more about growing sugarcane in the tropics with the reef in mind. Project Catalyst is funded by the partnership between the Australian Government's Reef Trust and the Great Barrier Reef Foundation, in conjunction with the Coca-Cola Foundation and with support from WWF Australia.